Welcome back, recruit. Excellent work. Let's have a quick debriefing to see how you were able to accomplish your tasks. The first thing you did was create an encryption function, and there's many ways to do this, but one possible way that we'll show in this debriefing is to, first off, create a placeholder list. We will say encrypted text is equal to a list, range, length of the text. So what is this actually going to be? Well, this is just a list of numbers where every number stands for in place of a character in that actual text. So let's just see what this looks like if we were to run it. And then let's define our text as hello, and we'll see what that encrypted text looks like. So if we run this, we can see now we have a number for every letter here. That way we can quickly swap these numbers in and out for other letters. The reason we do this is because we can't exactly do that with a string. Coming back up here, we then want to create an alphabet and a shifted version of the alphabet. So we will say alphabet is equal to string, and we'll need to import string in order to use this. So we can do that just above here, import string, and we'll say string ASCII underscore lowercase. So that's our alphabet, and we'll create a shifted version of the alphabet. And the first half is going to be equal to the normal alphabet, starting from the beginning all the way to the shift index point. And then the second half of the alphabet will be the normal alphabet, starting from the shift index, colon, all the way to the end. Then we will have a shifted alphabet equal to the second half concatenated with the first half. And so that's basically just taking that end and then sticking it back in the front. And now we have a shifted alphabet, so now it's time to actually create a for loop that does the translation from the normal plain text message to the encrypted message. So we're going to do that here. We can remove all this comments. We'll use enumerate for convenience. We'll for I comma letter and enumerate text, and we're going to lowercase all the text. That way we can do our comparisons. If the letter is in the normal alphabet, which basically indicates that it's not a space, we'll do something here. So right now pass. Else, we're dealing with punctuation or a space, and in that case, we will say that our encrypted text list at that index point is just equal to the letter. So what we're doing here is we have our input text. That's the actual message that we want to encrypt. And we have this encrypted text, which essentially just looks like a list of numbers with the same length as whatever the text was. We're going to, using the enumerate function, go through every single character in this message. And then if that letter or character is in the alphabet, meaning it's an actual letter, not just a space or punctuation, we're going to do something. So we still need to figure that out. Otherwise, if it's not in the alphabet, that means it's a period or a punctuation or a space or something else, and we'll just keep it that way. We'll say encrypted text at that index point is equal to that letter. And a better word or variable name here may be just character instead of letter. Now, if the letter is in the alphabet, we will say the original index position of that letter is equal to alphabet, and we'll call the index method and find the letter position. And then we can say that the new letter is equal to shifted alphabet from the original index. And then my encrypted text at index I will be equal to that new letter. So let's explain the logic here. We're going through every single lowercase letter in this text. If that character happens to be in the alphabet, meaning something like if A, in, and then we have A, B, C, D, etc. So we have all of that, then we're dealing with an actual letter. If it's not, then we just set it to whatever it was. If it is in the alphabet, then we grab the original index location of that letter in the alphabet. So for example, letter A would be 0, letter B would be 1, letter C would be 2, on and so on. And the new letter that's going to be its replacement will be the shifted alphabet at the original index point. So then we'll go to that index point location, 0, 1, or 2, and then grab whatever that letter happens to be, since we shifted the alphabet by doing that split. Once we do that, we can assign that new letter location. And then finally, we can just return the encrypted text. However, if you just return the encrypted text, it's actually still a list, so we can join it together as a string by saying join the encrypted text with no space string. Let's run this and see if it worked. So we'll say get this message to the main server, and we got the exact same results. Now it's time to create a decryption function, and that's pretty much going to be the exact same thing, except the alphabets will be switched. So we can actually just copy and paste all the work we did here. So I will copy this, come down, and paste it in. But now all we're doing is, instead of using the original index and the alphabet, it's essentially reversed. So the index we're going to be using, well, we'll just rewrite the lines here. We'll say if letter in alphabet, then we'll find the original index position. We'll say index is equal to shifted alphabet dot index at that letter. Then the original letter is equal to the original alphabet at that index location. And then we will say, let's make decrypted text instead of encrypted text. So let's delete this. We'll say decrypted text at point I is equal to the original letter. And then we'll change this up here. So instead of encrypted text, it's decrypted text. So decrypted text, we still have the same alphabet. We still have first half, second half, and the shifted alphabet itself. We're still doing the same for loop. The only thing that switched was basically the alphabet order here. We'll start with the shifted alphabet and then find its location in the original plain alphabet. And then in case we have punctuation or something, we'll just keep the same character or letter there. And then we'll join decrypted text. So let's run this, make sure we didn't get any typos. And it looks like it was able to decrypt this message, get this message to the main server. Finally, there's the brute force method, which is essentially just printing out every single possibility. And that's quite easy if we just use our previous decrypt method. We'll do the following. We'll say for n in range 26, because those are pretty much all the possible shifts. We're going to print using a shift value of, and then we'll say dot format n. We will print decrypt the message with that value of n, and then print a new line. So if we run that, there we can see the brute force values, all the values being used, the result, and you can scroll down until you find something that you can actually read in English, such as this one, get this message to the main server. Okay, let's quickly go over the logic of the main encryption decryption function one last time to make sure everyone understands it. So the logic here for encryption was to first create some sort of placeholder. Here we created a list that acted as our placeholder so that later on we could inject characters into that list. So right now it just starts off as numbers. Then we have our plain alphabet. We create our shifted alphabet by grabbing the n and then sticking it in the front based off wherever that shift point was. Then we say for I letter in enumerate, and we're going to lowercase all the text. That way we can use this lowercase alphabet. If that letter or character is in the alphabet, we're going to find that letter's location, the index location in the original alphabet, save that to original index. Then once we know that original index location, we will find out in the shifted alphabet what new letter that is. So we'll pass that original index into the shifted alphabet, index off the new letter, and then inside of our encrypted text, we'll replace that actual index location at I with the new letter. If it wasn't in the alphabet, we just encrypt it with the current existing letter. Then we join it all together to get back some sort of string output. All right, excellent work, agent. We'll see you at the next lesson.